Hello, in the last lecture we have seen structures of some fancy yarns, and in this lecture we are going to see the production methods that are available to produce these particular effects. So let us see the production methods. The fancy yarns discussed in this session can be produced by the following methods. So the first method is the ring spinning, in which marl yarns and spiral yarns are easily made. The second method is the plying technique, which is a two-stage process where gimp, boucle, loop and snarl yarns can easily be made. The hollow spindle system, which can produce boucle, loop and snarl yarns. And also we shall see the DREF2 alternative spinning system, which can easily produce loop yarns also. So coming to the first type, or the ring spinning for the production of marl and spiral yarns. If you remember from our earlier lecture, the marl and spiral yarns are the easiest or the simplest structures to produce. So we do not require a lot of complex production method for this. Simply a ring spinning machine can produce marl or spiral yarns. For some fancy double yarns such as marl and spiral yarns that are structurally relatively straightforward, the additional process of binding is not required. In both these yarns, we do not require any kind of binding, and that is why the ring spinning system can easily produce these yarns. So this is the marl yarn structure. If you recollect from our earlier lecture, it is simply two different colored yarns are taken and plied together. Whereas even in spiral structure, it is only simply two yarns that are there, maybe of differing counts or differing twist, or one being overfed. So spiral yarns are produced in that manner, and again it is a simple structure. It does not require a binder yarn for this, so it can easily be produced by normal doubling or the ring spinning, ring and traveler twisting process. So the second type, that is the plying technique, as I already mentioned, it is a two-stage process, and two stages are required to produce whether it is jimp, boucle, loop or snarl yarns that are slightly complex when you compare it with the marl yarns or the spiral yarns. So coming to the production method, which is the plying technique. So let us understand how this is done. In producing some effects such as jimp yarn, for example, the initial twisting process only lays the foundation for the desired effect, and therefore a reverse twisting is required to make the effect visible. So during studying the structure of the jimp yarn, we have seen that it gives you a more enhanced effect when you compare it with the spiral yarn, and that is because of this reverse twisting that is done by using the binder yarn, which makes it the effect more visible. So this is how the jimp yarn looks. And for most other effects, that is loop yarns, the snarls or the boucles, the effect yarn or the yarns may appear to be twisted in by the ground yarns. We have seen that it requires two ground yarns to make these particular yarns, loop, snarl or boucle. And it is somewhat, one may assume that the ground yarns will hold on to the effect and keep it in place, but that does not seem to be the case. And to keep those strands or the effect in its original position and avoid from it being sliding over the surface of the yarn, to avoid that, we need one more twisting process with the binder yarn, and therefore it is necessary to bind the effects to the ground yarn or yarns by twisting in one or more binder yarns, so as to prevent the effects from sliding along the yarn length during the subsequent processing. So this is an additional twisting process. So we require two stages, one where the ground and the effect is brought together, and the second stage where the binder is made to twist along with the uh, previously made combined yarn, where your effect and ground is brought together. So coming to this, some important tips which we should remember during the production of jimp, boucle, loop and snarl. In order to ensure that the effects are made stable enough for subsequent handling, the initial twist level is usually high. This produces a hard, lean and twist lively yarn. The final twisting is always in the opposite direction to the initial twisting, and this is used to set the fancy yarn twist to the correct level to achieve the desired yarn character, which may be, for example, a soft or open look. Um, Also, around 80 to 85% of the fancy yarns require this final twisting process, which adjusts the appearance and structure of the completed yarn while binding all the components together. So, we need to keep these points in mind while producing these four types of yarns. So, plying technique for the production of fancy yarns. Plying is the conventional method for producing fancy yarns. There are two stages to this process. The first one, I have already mentioned, it is the profile twisting stage. It involves the ground and the effect components which are brought together. Then there is this binding stage where the binder is introduced to stabilize the profile. Specially made ring twisting machines are employed, particularly for the first stage, where the threading of the component yarn is important to obtain the required profile. So there has to be some modifications in the normal doubling machine to take care of this bringing together of the ground and the effect components. We shall shortly see why those modifications are necessary. So let us see the passage of yarn while producing this fancy yarn. The first stage where we are bringing together ground and the effect, which is known as profile twisting. So this is the side view of the passage where the core yarn is coming out of the back rollers, which is controlled by the back roller, and we also see that the front rollers seems to be controlling both the effect and the core, which is not the case, which is not visible in this particular side view of this passage. For to understand how the core yarn is only controlled by the back roller and the effect yarn is only controlled by the front roller, we need to see the other view of this particular front roller pair over here. So let us understand this. The front rollers must not interfere with the controlled running of the ground yarns, and therefore to ensure this, either a substantially higher count of yarn is used, its thickness preventing the nipping of the ground yarn by the front roller. So to understand this better, let us take a look at this particular image here, where this is the front pair of rollers, the top and the bottom, and this black one, the thick yarn, is the effect yarn, and on either side we see the ground yarns that are there. Since this effect yarn is substantially thicker when compared to the ground yarns, it will lift this particular roller and allow the easy passage of ground yarns through this nip without controlling them. So the top roller is lifted by the thicker effect yarn and cannot exert any nip pressure on the ground yarns. Although from the side view it appeared as if the core yarn was passing through both the sets of or the pair of rollers, it is effectively only being controlled by the back rollers, and this it is simply passing through the to the front roller nip without any control as shown here. Or the second way of ensuring that there is absolutely no control of the front pair on the ground yarns is to cut grooves on the circumference of the front top roller as is shown here. So in this case also we are 100% sure that the ground yarns are not controlled by the front roller pair. This is done by cutting grooves in the top front roller, and the ground yarns are made to pass after coming out of the back roller. They are made to pass through these grooves, so that they are by no ways they are controlled by the front roller, and the effect yarn is passing through the middle region over here, which will control the effect yarn only. So having seen this mechanism, we come to the profile twisting of fancy yarns, where this is the second stage, where in the first stage we bring the effect yarn and the ground yarn together. The production rate is and the twist insertion is usually calculated only by the surface speed of the rollers controlling the ground yarn. In this particular situation, we saw that the ground yarns are controlled by the back roller, so the production rate is going to be calculated based on the surface speed of the back roller only. Also, the twist insertion is going to be calculated considering the surface speed of the back roller, because it is controlling the ground yarns. As explained earlier, the length of effect yarn needed to form a desired profile is obtained by the percentage overfeed. Therefore, the speed of the front roller must be greater than the back roller here. As we have seen that to produce any kind of effect, say here there is a loop which is shown here. To produce this effect of loop, we might have to feed an excess length of effect yarn which is required to be fed by the front roller, which is controlling it, and therefore to have this kind of overfeed, The speed of the front roller must be greater than that of the back roller, so that we have an extra length of effect yarn which will create this texture on the surface. When producing regular effect yarn, suppose we are producing a regular normal effect yarn where we do not require an overfeed, in that case both sets of rollers are run at a constant speed. The rollers would normally be computer controlled so as to produce randomized effect yarns. The front rollers can be rapidly slowed to the same speed as the back roller and then accelerated to its original speed. So this facility is available where the front roller can be accelerated or slowed down to give the desired length of effect along the length of the fancy yarn that we are producing. So we can this is done so that we can have random intervals between the repeats of the profile. So by changing this, having this facility to change the speed, I can produce different textures or different modifications in the same type of yarn where we can have different loop length, loop sizes, depending on how we have accelerated or slowed down this particular front roller speed. So speed control of the rollers enables the construction of yarns with different profiles. So having seen these modifications, we come to the second stage, that is the binding stage, where a reverse twist is usually applied using a binder yarn. If the profile twist is of, say in the earlier twisting or the profile twisting stage, we have introduced Z twist into the while bringing the ground and the effect yarn together. The binding twist here in the second stage would be in the opposite direction, that is the X direction, so as to obtain a balanced yarn. So the profile yarn is commonly twisted with a filament yarn, the latter having a slight overfeed of 102 to 105%. The filament yarn therefore wraps or binds the profile yarn, hence the reference to it as a binding component. Because it binds, it is called as a binding component in the structure. So having seen the modifications etc., let us come to a specific passage of yarn in case of boucle yarn. We have already seen the structure, how the yarn is made. So let us see how the passage of the yarn goes over here. So the ground yarns are fed through the grooves in the top front roller, while the effect yarns are fed by the front roller nib. So as we can see here, the ground yarns are coming through the back rollers, which is also controlling these ground yarns, and the effect yarn is only passing through the front roller nib. The ground yarns, as it is being brought to the front, it is passing through the grooved front roller pair, so that these grooves do not help in not controlling these ground yarns. So as we have already discussed this, ground yarns are only controlled by the back rollers, whereas the effect yarn is only controlled by the front roller over here. The overfed yarn, the effect must be fed through the shortest distance. So we could have, one may say that why not let the effect yarn be controlled by the back rollers and let the ground yarn be controlled and just reverse this position over here. But it is seen that if the overfed, whatever effect yarn, since it needs to be overfed, it is best controlled if it is having a short distance after it comes out and before it gets twisted. So normally one would find that the effect yarn is controlled by the front roller pair only. So coming to the loop yarn passage, now loop yarn is also a similar yarn, and the passage is similar to that of the earlier passage that we have seen. So two ground yarns must always be used while creating a loop yarn. These two ground yarns are fed by the back feed roller, similar to the earlier passage that we just saw, while the effect yarn is fed through the front roller. Effect yarn is coming through the front roller. As the ground yarns and the effect yarns are fed at different speeds, the ground yarns are made to pass through the grooves cut in the top front roller instead of being nipped as they would be if the grooves were not in place. So these grooves are of most important, have got an important function over here, because the effect yarn in case of loop yarn would be fed to the extent of 200% higher than the ground yarns, and therefore the speed of this particular pair would be different or higher than that of the back roller speed, and that's why the grooves help in not controlling the ground yarns by the front roller pair. This allows the ground yarn and the effect yarn to converge in the twisting zone after they have emerged from the front roller. So after they have come out from the front roller, here at the bottom they would form a sort of a spinning triangle over there, and they converge in the twisting zone. The two ground yarns, kept separated by the two grooves, form a triangle, which is known as a spinning triangle between the front roller and a twisting point at which they come together. So between the twisting point and the grip over here, or rather the passage where the ground yarns are coming out, they form a small triangle. This triangle provides the essential space in which the overfed effect can form the loops. So just before being twisted, there is an opportunity for the effect yarn, suppose in this case loop yarn over here, to form the loops in that particular spinning triangle region before being twisted finally. So in order to maintain good control of the yarn, the effect yarn which is overfed and therefore not under tension between the feed roller and the twisting zone, so as we have already mentioned, it is being controlled by the front roller. It is because we do not want to exert a lot of tension on the effect yarn, and therefore it is fed by the rollers that are closest to the twisting zone, which is the front rollers. It is also important that the effect yarn should be fed in such a way that the ground yarns are placed one on each side of it. So as you can see the passage, the effect yarn is in the center and the ground yarns are fed on either side of it. So factors deciding the size of the loop. In case of a loop yarn, what are the factors that decide the size of the loop that is formed on the surface? The yarn effect is critically dependent on the combination of factor, that is the overfeed ratio, that is the ratio of the effect yarn speed to the ground yarn speed, the twist, the groove spacing, that is the spacing between the grooves on the front top roller, as well as the properties of the component yarn. All these factors will decide the size of the loop. In order to produce good loop effects, the effect yarn should be stable, that is it should display low twist liveliness and elasticity. The loop size can be altered by changing the size of the spinning triangle. I've already mentioned what is a spinning triangle in the earlier slide, and the size of the spinning triangle will decide the loop size also, and also the overfeed ratio will decide the loop size. The spinning triangle can be changed by altering the spinning tension, the twist level, and the top roller groove space. So all these three factors will can you by you changing this we can change the spinning triangle, but the most economical method would be to change the twist levels. If the twist level of the loop yarn being produced is used to control, suppose since we say that this is the most economical method, if we are going to use this method to control the spinning triangle, then we should know how it is being controlled and what is the effect on the final yarn. So if the twist level of the loop yarn is that is being produced is used to control the size of the loop, it will be at the same time affect the slip resistance of the loops. We should understand that if we change the twist level, it will also change the slip resistance of the loops. For example, let us say that we have increased the twist level in the final yarn, then in that case the yarn twisting torque is increased, and this causes the twisting point to move towards the front drafting rollers. So that means the twisting point would go further towards the drafting rollers if we were to increase the twist levels, and therefore it results in reducing the spinning triangle. The spinning triangle becomes smaller. So because of the higher twist, the loops will have a greater resistance to slippage. Since the twist levels are high, we would have greater resistance to slippage. But what happens is the yarn will become harder, although it is possible to rectify this later during the binding process. The yarn at this stage will tend to become harder, but by reverse twisting in the binding process, the hardness can be slightly controlled. So these are the various ways to decide or change the size of the loop. So let us come to the hollow spindle system, which is another system, which is an alternate spinning system, which we have learned earlier. How this particular system can be used to produce the boucle loop or the snarl yarns. So many of the effects described may be produced by using the modified ring spinning and the hollow spindle system, or by using a combined system. So normally in the normal yarn production by the hollow spindle spinning system, what it does is it will have a twistless core. It replaces the twist in the yarn by wrapping a filament binder around the material being used. We have seen this process or this hollow spindle spinning process in detail earlier. A normal yarn would be produced in this manner, which would result in a fasciated yarn structure in which most of the fibers or the elements lie parallel to one another while the binder imparts the necessary cohesion to this particular yarn. This system is suitable for making plain, as well as now we shall see how they are used to make the fancy yarns. Snarl, loop and boucle yarns may be produced using the hollow spindle system or the combined system machines in one single step. We have seen earlier in this particular session that to produce boucle, loop or the snarl yarns, we need a two-step process plying technique, where in the first step, in the profile twisting step, we have brought the ground and the effect yarn together, and then we go for a binding stage, and we require two steps to produce this particular final yarn. But if you are using this hollow spindle system, one advantage is that this entire both the stages can be clubbed into one, and one single step will produce this final snarl or the loop yarn. So the modified spindles and the hollow spindle system produce a superficially similar yarns. So we should have some amount of caution here that both the yarns produced by these two systems will look similar in look. Superficially it will look similar by both these methods, but the structure will differ, and therefore the properties will also be different in both the yarns produced by the earlier plying technique or by the hollow spindle system. So let us first understand how we can make the fancy yarns on a hollow spindle system, and then we shall also go into the details of how these structures are going to be different. So if you recollect the hollow spindle system from our earlier lecture, so this is your hollow spindle and a binder bobbin that is there. The binder yarn is being mounted on the hollow spindle, and in this particular example here there are 4 independent feeding devices, 3 for effect and 1 for core. So let us trace this. One is the core that is coming through directly via this particular passage, and there are these effect yarns which are coming through 3 different drafting systems here, and they are being combined at this stage, and then the binder which is there on the hollow spindle would bind this effect and ground all together and giving us the final fancy yarn. The effect fibers are fed in the form of staple roving or sliver. They are drafting using roller drafting systems that are similar to those used on the ring frames. The effect fibers are combined with the core yarns, and then they are passed through the rotating hollow spindle. So we know that whatever material passes through the hollow spindle will come out without any being twisted, just like how we produce the fasciated yarn there in the normal yarn. And the binder would actually twist the effect and the ground, whatever is formed effect is formed in this region, it will be bound by this binder, and we will get the final yarn in one single step. So a bobbin bearing the binder, usually a filament yarn, is mounted on the hollow spindle and rotates with it. So the binder is pulled into the hollow spindle from the top. The rotation of the hollow spindle wraps the binder around the staple strand and the core yarns. So whatever effect has been produced, they are bound by this particular binder. So the binder then holds the effect and the core yarns in place. So as we have seen, it happens in one single step. To avoid the possibility of drafted staple strand disintegrating before it is wrapped by the binder, the spindle usually generates false twist in the staple strand. So the spindle will produce a false twist into this particular strand so as to avoid the effect and the core yarn falling apart, because sometimes the effect yarn consists of say staple fibers or the sliver that is being drafted and being fed. So to avoid it being disintegrating it in this region, a false twist is introduced in the staple strand. The staple strand does not therefore pass directly through the hollow spindle. It is not directly passing. It is first wrapped around a twist regulator, which is shown here, which is located at the bottom of the spindle, which will be the reason for introducing a false twist into this region, and therefore avoiding the disintegration. A very wide range of fancy effects can be produced using the hollow spindle system. Many of these effects can be controlled by controlling the speed of each of the different feeding devices, core and effect. By controlling the speeds of this, we can have a variety of or a wide range of fancy effects that can be produced. It is also possible to use the hollow spindle system to create fancy yarns that include effect yarns. Still more effects can be produced by controlling the final yarn delivery speed. So still more effects can be produced by controlling this final delivery speed. Because the effect fibers do not have a real twist, hollow spindle yarns differ from the ring or the doubled yarn or the plying technique yarns in both their appearance as well as the performance characteristics. The hollow spindle yarns tend to be bulkier and have lower wear resistance. As we can see here, in the earlier plying technique, we had two stages where the ground and the effect yarn would be twisted together, and then they would again be twisted by the binder. So it ensures that there is enough twist to hold the effect as well as the ground together, and then to it also ensures further by having a binder yarn in the plying technique. But in this case, as we can see here, whatever effect and ground yarns are brought together over here, they are immediately, they are not twisted amongst each other but are directly twisted by the binder yarn, and they are kept in place. So there is a significant difference in the structure of the yarn produced by both these methods, and therefore the yarns produced by the hollow spindle technique would be bulkier, of course, but will also have a lower wear resistance. So with this background, let us take a look at the video of this particular hollow spindle system, and it shall be quite clear by looking at this video how this yarn is made on a hollow spindle system that is being fed at the behind in the creel. So having seen this, having a fair idea of how this machine works, um, let us see what are the advantages that are there in the hollow spindle system. Although the yarns are superficially similar, as we have already mentioned, the yarns in the way of look would be both ply technique as well as hollow spindle system would give you similar looking yarns, but they may appear to be structurally similar. But fancy yarns made using the hollow spindle system are quite different in structure from those made by the normal conventional ring spinning system, and are likely to differ also in details of appearance and of behavior during processing. So fancy yarns can be made using a single passage of the machine. So advantage here is that it is made in a single passage of the machine, while minimum two passages would be needed for a similar yarn made using the ring system. In producing hollow spindle yarns, whether fancy or plain, fewer preparatory processes are required done for ring spinning. For example, in particular, it is no longer necessary to produce a roving as an intermediate process between the sliver and the yarn. Even in the video, we saw that we can easily feed slivers, have them drafted, and use them as an effect. For example, the boucle effect can be created in a single operation, as the effect fibers or yarn and the ground yarn are bound by the binder without twist. So it is a advantage is that the yarn can be produced in a single step and eliminate a lot of preparatory processes. But at the same time, there will be some disadvantages. In the production of fancy yarns, the hollow spindle technique is used to add the binder immediately after the effect is produced instead of using a second separate operation. So since there is no twist holding the elements of the fancy yarn together, it has no cohesion beyond that imparted by the binder. As I have just mentioned, that the ground and the effect are not twisted amongst themselves as it was done in the plying technique, and therefore it will have lesser cohesion. This particular yarn produced by hollow spindle will have lesser cohesion when compared to the other type, and the cohesion in the hollow spindle type would be only to the extent that is imparted by the binder. If the binder breaks, the entire yarn falls apart into separate components more easily and dramatically than the fancy yarn that is produced by the earlier or the plying technique or the ring spinning technique. Furthermore, a filament binder. Suppose we are using a filament binder. In a filament binder, to identify a weak spot is relatively difficult, and therefore it will break without any kind of warning, and therefore it is more likely to affect the structure of the final yarn. So since the filament binder is unlikely to show any thin places, and without warning it will just break off. So coming to the next system that can be used to produce the loop yarns, here is that is the of DREF2. We have already studied this DREF2 spinning system in detail earlier. So let us see how this can be used to produce the loop yarn. Loop profiles, largely boucle, can be also produced with this spinning system. The ground and the profile yarns are made to run along the nip line of the friction rollers. We know that the uh, the material is made to run along the nip line of the friction rollers, with only the ground yarns that are kept under tension. So along the nip line, when we are feeding these effect and the ground yarns, only the ground yarns are kept under tension, and the effect yarns that is having a lower tension will undergo a suction at this nip line. The suction at the nip line causes the profile yarn to buckle into a sinusoidal shape along its length. The friction rollers twist the components together, causing the undulations of the profile yarn, that is whatever deformations that have taken place in the profile yarn, they will be twisted together, and they will become small loops over there. So individual fibers from a light feed to the opening roller are simultaneously being deposited onto the friction rollers and twisted around the ground and profile component, thereby binding the loops in the place. So to bind, the idea here is that we are feeding individual fibers, and those individual fibers will be deposited onto the friction rollers, and they are twisted around the ground and profile component, thereby binding or keeping the loops in place. So like the DREF2 process, the hollow spindle technique combines the profile twisting and binding stages in one process. The separation of twisting and the winding actions enables faster production speeds. So the advantage here is that we have a faster production and larger package sizes to be wound. Therefore, there are obvious economic advantages over the conventional prying process. So in contrast to the friction spinning technique, hollow spindle wrap spinning has the flexibility to produce most of the 8 profiles. So one can say that hollow spindle is more popular for the production of fancy yarns, because it can produce most of all the 8 profiles that we have classified the fancy yarns into, and also it can produce the yarn in a single step. So coming to having learned all this, let us have a small discussion on the observations of this entire session. The ring spinning system is still the most flexible yarn production system in terms of both raw material handling and the range of yarn counts being produced. Its main drawback lies in the lengthy and costly processes involved in the production by this route. When produced using the ring spinning route, most fancy yarns require several twisting processes. As we have seen, to produce a slightly complicated fancy yarn, we have seen in case of spiral, snarl, loop, that we already need 2 steps to produce them. Um, the loop yarn, for example, requires a minimum of 4 component yarns, 2 ground, 1 effect, and 1 binder. Each component yarn has to be spun separately. If you are using this system, we will need to have these 4 components ready before we bring them together. The ground yarns and the effect yarns are then twisted together, and this process is followed by the final twisting. So there are various steps that are involved when you have to produce, say, loop yarn, snarl yarn. It is not a single step or a single stage mechanism. We need to have these components prepared earlier, to bringing the ground and the effect together, and then a second stage which needs to bind them. Thus, even if we do not include the production of the component yarn, 2 separate stages are always going to be involved. So since it is by no means unknown for 2 fancy yarns to be twisted together to produce other still more complex effects, the number of twisting processes involved can increase at an alarming rate. So this statement particularly tells us that if we are using 2 fancy yarns which are being again twisted together to produce a still more complex effect, then in that case we will require another twisting stage, and so on. The more complicated the fancy yarn that one needs to produce, the number of stages will keep on increasing, and this could increase at an alarming rate. In recent years, alternative techniques for making fancy yarns in a single stage process have emerged. and become more popular. As we have already seen, alternative techniques that we have studied earlier to make the normal yarn can also be used to produce fancy yarns of loop types, where DREF is also used, as well as hollow spindle technique is used to make these fancy yarns. The most widely used of all these new techniques is the hollow spindle system. We have seen how easy it is to produce on a hollow spindle system, just in a single stage, without any much of preparation that might be required otherwise. So, summarizing the fancy effect production methods, let us see a summary chart or a diagram here. Fancy yarns are produced either by plying techniques, where the various components are in the form of yarns, or by spinning, where the effect component can be a ribbon of fibers, a yarn, or a combination of both. So we can have all these kinds, where we can either use sliver, roving to make this particular yarn. So fancy yarn systems, they are, you can put them in this particular chart. The twisting process, fancy twisting or doubling frame, plying of non-effect or of effect yarns. Then we have other systems that are spinning processes, that is applying technique, which is ring spinning. It's mentioned, it's called ring spinning throughout. And then we have hollow spindle spinning. We can have DREF friction. We can also use Repco spinning, Cyro, as well as felting techniques to produce certain fancy effects. And another process that is involved in making of fancy yarns, the system is that brushing process, where we can produce hairy yarns by light brushing. Just to elaborate a little bit on this particular brushing, in the brushing process, the staple yarn is brought into contact. Now this brushing, we have seen earlier in our earlier lecture, where we saw the loop yarn, the loops were opened out by brushing to give a more softer yarn, and the loops would disappear, and whatever yarn that is forming the loops would open out and give you that kind of texture on the surface. So this is basically the process by how it is made. In this process, the staple yarn is brought into contact with a rotating cylinder fitted with a flexible card clothing. So you basically need is a roller having a flexible card clothing on it, and the yarn is made to rotate in the, and the direction of rotation enables a back of the tooth action. That means the teeth that is there on the card clothing would basically open out these loops to partially pull out fibers and provide a hairy yarn surface. The purpose is only to produce hairy yarns and not to construct definite features. So the outcome or the output of this particular brushing action will give you only a hairy yarn, and really not a texture, as we have seen in other or all the other fancy yarn structures that we have seen. Brushing will only produce a sort of hairy yarn. So with this we come to the end of this production method lecture. Thank you.